Hello, my name is Jen-mei Chang, a professor of mathematics in the Department of Mathematics and Statistics at California State University, Long Beach. I would like to talk to you briefly about what to expect in the Introduction of Linear Algebra course M247 at Cal State, Long Beach. Well, let's look ahead a little bit. Hopefully at the end of this course you'll have learned and acquired all of the languages and skills to solve problems, such as this following example. Given a set of four experimental data points in order pairs. The first point has the coordinates x1, y1 as labeled. The second point x2, y2. The third point x3, y3. And the fourth point x4, y4. Scientists are typically interested in making predictions from known information. This typically translates to modeling the data points with some types of function and making forecasts and predictions based on that model, which is a very useful tool in industry. The most common model used in practice is called a linear regression model, also known as line of best fit. So, a natural question to ask when we are given a set of data points is, what is the line of best fit, and how accurate it is to model the data point with such line? By the end of this class, you will know how to do this exactly. That is, if you keep up with the course materials. Next, let's talk about why everyone needs to have some background knowledge of linear algebra. First of all, linear algebra has become the single most useful body of mathematics that is landing its structure in nearly all scientific and most of non-scientific fields. It is used in engineering, other areas of mathematics such as graph theory and stochastic processes, digital art such as popular drawing software like Adobe Photoshop, and other scientific disciplines such as physics and chemistry. The list goes on and on and on. In fact, there is no branch of science which does not apply linear algebra. That is perhaps why we demand this course as a prerequisite for all programs in the sciences. The study of linear algebra consists of a rich blend of theory and computation, which makes it an excellent medium for teaching and learning general problem-solving skills. In general, we expect students to acquire content knowledge as well as general skills when they're in a math course. I will provide a roadmap to each of those two domain knowledge here. But before I do that, I want to remind you of one thing. In general, we don't expect students to remember everything they learned in the math course after 2 years, or even after a year, or even more realistically speaking, a semester. Instead, what we do expect students to have developed is an intrinsic appreciation to the field they studied. If we happen to have done it right, we would love it if students have gained some lifelong problem-solving and critical thinking skills through the process of solving these content-specific problems. Thus, I want you to practice getting better at those skills that are transferable to novel settings as you progress through the course. Now we're ready to discuss specific student learning outcomes for this class. We will start with the lifelong skills. First, communication skills. You will be asked to contribute your ideas constantly in small and large group discussions. Through those discussions, you will practice explaining mathematics in an easy-to-follow fashion and convincing your fellow students that your idea is worth pursuing. Having to explain things to your peers and your teachers could be intimidating, particularly if you're not confident about your abilities. I would like for you to build that confidence through many discussions as well as the final project presentation. Second, independent learning skills. Since this class is very different from the way a conventional class is run, you're responsible for many reading and learning on your own prior to class meetings. This aspect of the course forces you to create primary information, also known as the first-hand information, which is essential in becoming a critical thinker. You will learn to explore information, digest it, and then piece multiple evidences together to form concepts. Since it's unlikely that someone else will be there to lead you or feed you the solutions when you are in the workforce, it is better that you learn how to be an independent learner now when you still have the opportunity to practice doing so. Third, writing skills. In my experiences, this is the one area where math and science students typically pay the least attention to. Math and science students feel that they go into this area of study because they can avoid writing. Well, that turns out to be very wrong. In order for people to understand, accept your novel ideas, you will have to convince them through scientifically sound writings. Hence, when you take notes in class or write your homework assignments, you should be writing it to convince the readers that the statements are supported accurately. Moreover, an organized and well-supported notes will allow you to learn ideas more efficiently. You will get to practice good note-taking and writing skills through numerous homework assignments where you'll be asked to explain your thoughts with constructed reasoning. Fourth, organization skills. There are going to be a lot of things to keep track of in this class, and they are purposely so to provide you with the opportunity to appreciate the benefit of being organized. In a real job, you're likely to have to juggle around many tasks at one time. How you set priorities and accomplish things on time will be one of your learning goals in this class. And the fifth, problem-solving skills. Most of the interesting problems that are worth solving don't come in small pieces on their own. Moreover, it is rarely the case where the amount of information you need to solve the problem match exactly with the amount of information you are given, without any redundancy. I'm confident, with the probability of 0, that the problems you will learn to solve in the textbook will appear elsewhere in real life in their exact form. So I guess you had a point there when you asked your math teachers when you're ever going to use this math in life. Because it's most likely that you won't. At least problems won't be described in those exact same language. So, what do we mean by problem-solving skills? You can develop those skills through the following steps. 1. Identify evidences that support the problem thesis. 2. Research sound methods to solve the problems. 3. Recognize it when the method works or fails by verifying your solutions. 4. Examine whether the claimed solutions make sense. And 5. Be ready to repeat this cycle as many times as needed until the problem is solved. If you can accomplish these 5 steps without getting furiously frustrated, I would say you have become a proficient problem solver. Next, we move on to the content knowledge. We will start the class with the method to solve large systems of linear equations and really get to know our best buddy, vectors. It turns out that nowadays computers can manipulate very large systems of equation in the blink of an eye. The computational aspect of this problem has become less interesting. Rather, the conceptual understanding of this problem is what you should emphasize on. The next module is on matrices and transformations, realized as matrix representations. The language used here will serve as the fundamental tool in many areas of mathematics. A module on eigenvalues and eigenvectors will certainly not be missed, considering that this eigenstuff is the single most useful idea everywhere. If you choose to remember only one thing very well from this class, eigenvector is your guy. The idea of orthogonality, projections, Gram-Schmidt process, and least squares problem form the ultimate module in this class. It will require your knowledge on everything you have learned in this class. And one of the most beautiful ideas is bases and vector spaces. Though the most abstract module, it will certainly provide a rich set of problems for you to practice those lifelong skills mentioned earlier. I hope this brief overview of the course has not scared you away from the class, but allows you to reflect upon your own expected learning outcomes. If my set of student learning outcomes does not align with yours, I suggest you either find a different course to take or talk to me directly about how I might help you to get more comfortable with my SLOs. Have fun, and I hope you will be able to look at yourself at the end of the semester and say, oh boy, I have learned so much and I can really put these skills to use in my current or future job.